Thank you for joining me today. We are going to be talking about um, frameworks in iOS, and we won't be doing anything actually if I can't get the slides to change. 1 second. Let's figure out why that's not working. Never a good sign. A beach ball. Oh, there we go. Huh. Well, okay. I guess we're done with the slides. All right, let's start that over again. Okay, so the topic today is frameworks, and basically we've been living in a world as iOS developers for a long time where we knew that Apple was using frameworks to organize the structure of their applications, and we were not allowed to participate. Basically, Apple, for whatever reasons, did not make frameworks available to third-party developers. And finally, with Xcode 6 and iOS 8, they have made those available. So what we're going to talk about today is why frameworks are useful, what they are, and how to use them in Xcode 6. Before we jump into that, just a brief introduction about FocalShift, the company that I and Terry Tucker run together. We're basically a small contracting firm to do software development for mobile apps, and pretty much exclusively iOS at this point. So we're going to talk about code reuse techniques for iOS. We're going to talk about what frameworks are, and then we're going to look at some demos of how we would go about using Xcode 6 to build a framework and use it in an app. So because we did not have frameworks or dynamic libraries available to us in iOS, there's a number of techniques that developers have used to try and make code reuse more palatable on the platform. And I've bullet pointed a couple of them here. The one that is probably the worst, but also the easiest, is just copy and paste. Then there's various ways you can use source code control systems like Subversion or Git to help you reuse code across applications. Then static libraries are sort of the supported way that Apple has let third parties reuse code. And there are a lot of shortcomings to static libraries that make them less than ideal for that purpose. An open source project called CocoaPods sprung up about 3.5 years ago to try and address some of the shortcomings of static libraries. And so a lot of people use that as a technique for code reuse. And then finally, we've got this new frameworks thing in iOS 8 that that is what we'll be actually looking at in the demo today. Okay, so just sort of a recap of each of these other techniques to sort of set the stage for frameworks. The simplest method was copy and paste coding. Obviously, really easy to get started with it. Really easy to take code off of places like Stack Overflow and just drop them straight into your application and go, hopefully. But there are shortcomings. The biggest one being it's very difficult to update that code for bug fixes or to add new features to it, especially if you're going across multiple projects. So it doesn't really lend itself very well to all of the things developers typically do after they've initially written the code. For the most part, the guidance from Apple or anybody else would be, don't do this, right? It's just not the best approach. Okay, I don't know what's going on with the slides, but it won't change again. There we go. Let's see. Okay, source code control. Hopefully you guys can see that. So there's a way, and probably a lot of people have played with this in the past. There's a way using Git or Subversion to set up multiple source code repositories and um, have some of your code, like the reusable model objects or something like this, sitting in a separate repository, and then kind of stitch those repos together into one project that Xcode can then build from. And this is actually not bad. It definitely gives you good code reuse, but a big downside to it is it's very tricky to manage multiple versions of your whatever that library is you're trying to reuse. So it's workable, and I'm sure there are projects that people are working on today that are still using this technique, but it's got some downsides that make it a little bit more difficult to manage. The third way, the way that Apple has supported for a long time, is using shared libraries. Static libraries. We've got the ability in Xcode to create a static library, which is basically a static library is just a bunch of object files that have been linked together into a .a file, and you can then include that .a file in your project when you build your project and pull in the code from that thing. It works reasonably well if you are in control of the library and the application. And the reason why it works in that scenario is typically then you have all the source code to the library as well. But if you're someone who's trying to build a library and maybe distribute it or share it with other development teams, then static libraries have some challenges. Two of the big challenges are not having any way to distribute the library along with header files, and then not being able to include like images or custom fonts or audio files in the library as resources. So not perfect, but it's what we've been dealing with for a long time. So I would imagine a lot of people are familiar with this technique. Then we've got CocoaPods. CocoaPods is actually a very nice environment for managing and sharing libraries of code. It's still built around the concept of static libraries, and what they do is they combine together the source code for one or more of these things they call a CocoaPod, which is like some little bit of reusable code that someone has made available. They combined all those things together into a single static library, and then they generate an Xcode workspace that wraps around your project plus this static library and makes all of that stuff link together and be reusable. Definitely a workable solution. It'll be interesting to see over the next few months what the CocoaPods folks do now that frameworks are available. We could almost imagine that CocoaPods will continue to be used, but there will be some way in which you define a pod that actually generates a framework, and then CocoaPods would just manage stitching together a number of frameworks into your application. We'll see. I don't actually know if that's going to happen, but I think it might be an interesting approach. And then finally, we've got the new kid on the block, frameworks. So frameworks have been around for a really long time on Mac OS. If you've built any kind of a large Mac OS application, you've already probably structured your app around frameworks. All of the stuff that Apple ships in iOS, things like MapKit or UIKit, those are all frameworks. So Apple has been using frameworks in iOS for a long time. They just haven't made them available to us. Now, one of the things about frameworks is typically they live in a system folder that is accessible by all of the applications running on the machine. And this may be one of the reasons why Apple didn't allow us to use frameworks, because everything is highly sandboxed in iOS. So the notion of having some executable code that's sitting out in a shared folder that can be dynamically loaded into any process is not something that they're interested in making available to us third-party developers. And up until Xcode 6, my hunch is they didn't have the plumbing in place in iOS to prevent us from doing that when we built a framework. The way frameworks are exposed to us in iOS 6 is through a concept called embedding, where we actually embed the framework directly into our application. So the bundle that sits on disk, the .app that we actually ship, or the IPA file that we upload to Apple, will actually contain our code, but it will also contain our framework code in a embedded bundle. And you can embed as many of these things as you want into an application. But the thing that makes it unique is now with iOS 8, we can create these frameworks, but they only work in that embedded kind of a deployment environment. We can't create a framework like if we had 2 or 3 iOS apps that we wanted to all share the same framework. We can't install the framework just once on an iOS device and have it be used from all 3 of those apps. That's not possible. We would actually end up shipping 3 copies of the framework, 1 copy installed with each of the applications that was loaded onto the machine. A big plus for frameworks is we actually can now incorporate resources and header files into the framework. Now, incorporating header files is of no use if you're building your frameworks in Swift, but if you're building them in Objective-C, it's critical that you're able to do that. Incorporating resource files like an image or a video clip or something like that into a framework is something that's appropriate both for Swift frameworks and for Objective-C frameworks. Okay, I mentioned one of these limitations already. So basically, you can't share the framework across multiple apps. The framework has to be embedded into the application bundle. And an interesting limitation is there are actually some UIKit API calls that you cannot make from within a framework if you plan on using that framework from an iOS 8 app extension. So if you've been following along on all the new iOS 8 stuff, you know that there are things like you can now create your own photo filter as an extension, and that filter would then show up as one of the options inside of the camera app. Or you could create your own Today widget that would show up whenever someone pulls down on the Today screen. Any of these various kinds of sort of augmentations of the UI that Apple provides is done through this notion of something they call an extension. Well, an extension is actually just a framework. It's a framework that has some additional rules, though. One of those additional rules being there are some API calls that you're not permitted to use. And if you link against those API calls, then most likely your app just won't even be accepted in review. So it's definitely a limitation that you have to be aware of if you're dealing with extensions. Okay, so what can we actually put in a framework? There's all kinds of things that would be useful for us to put in a framework. An obvious one is if we're building more than one application around sort of a shared problem domain, we'd probably like to group all of our model objects into a framework. We might even put all of our database logic into the framework. User interface views that are custom and might be shared across multiple apps can be put in the framework. So can view controllers. And then, as I've mentioned a couple times already, you could put resources in there. So all that stuff can be packaged together in the framework. Xcode takes care of linking it all against your app. Okay, so what does Xcode actually support in terms of building frameworks? There are 2 ways in which you can build a framework project. The first way is by simply adding a new target to an existing Xcode project. So if you've got a project that already has maybe all your domain objects plus some user interface in it, and you want to pull the domain objects out into a framework, an easy way to do that is you load up the existing project, you add a new target to it, and then you pull the objects out of your main application target that represent your model, and you include them into the new framework target, and now you've got a reusable framework for your model objects. That's sort of the simplest way if you're trying to migrate some existing code. A more sophisticated way that allows you to then easily share your framework across multiple projects is to start with a new Xcode project specifically for the framework. And so you can go in and you can create a new project file, tell it it's a framework, and then start pulling code out of your existing applications and inserting it into the framework project. Then, when it comes time to use that framework, you can drag that framework project into another Xcode project, like one of your apps. And Xcode will handle linking those two things together at build time, and it will embed the framework for you. Another thing Xcode provides for us with frameworks is a nice way to separate out unit tests for the code that is in each of these framework targets. So previously what people tended to do was they tended to possibly build multiple targets in their application that were little sort of bundles of tests that they would try and organize separately. Now you can kind of carry the tests along with the framework and keep them all nicely encapsulated, which I think is a nice advantage. It's better for sort of code management. Okay, excuse me. So let's jump into a demo. I want to give you a brief overview sort of what it is we're going to try to do in the demo, and then I'll go in, launch Xcode, and we'll walk through the process. So this is the app that we've got to look at, and it's basically a wish list app, and it doesn't do anything really other than have a hard-coded list of things that would be cool to play around with, right? And for each of the things that are in there, there's a domain object that contains a title, a URL, and an image, and it's a simple table view. And the current version of the app, everything is in one application. So what we're going to do is we're going to pull some stuff out and put it into a framework. So we're going to build, starting from the wish list app on the left-hand side of the screen, we're going to produce two new projects in Xcode. One is going to be the Wish app, and it's going to have all the UI stuff for this particular application. And then we're going to produce a framework called Wish Kit, which is going to have the model object and the images for how this framework is going to work. So it's not really a great example, but it'll let us work through the mechanics of how this stuff is done. So let's go over here to Xcode. Okay, so I'm going to start by just opening up the existing project and show you sort of the structure of how the thing works currently. Okay, so the you already saw it a little bit in the picture, but all of the examples that I'm running, all of this code is in Xcode 6.1, the beta release that is most current, because they haven't actually released the real version yet, or the release version. Oops. Okay. All right. So there's the app. It's a table view. It just has some stuff in it. Nothing too exciting. And you can see that there are some images that are stuck inside the app here. And each of these images is just included in the target membership for the application. And there's a custom table view cell that actually displays the content. If you look in the storyboard, you can see that here's the layout of that custom table view cell. So we're going to keep the storyboard and the table view cell in the application. What we're going to move is we're going to move all of the resources, and we're going to move this model object called the wish list item, which is the sort of the data of the application. We're going to move that stuff into a framework. And let's see, the table view for this application keeps track of the wish list items in a mutable array that's part of the table view controller. And this array is initialized from the app delegate by just constructing the array initially. So we construct a number of wish list items. We create a mutable array from those items, and then we inject that mutable array into the view controller so it can actually be rendered on the screen. All right, let's get started on the refactoring into the use of frameworks. So I'm going to leave this guy around so we can come back to it. Oops. And let's start creating a new project. So I'm going to go new project, and I'm going to create a single view application, and we're going to call it Wish App, and we'll put it on the desktop. Okay, so this is our new application. There's some code here that we don't really need. I'm going to copy code out of the old wish list app, the one that I just showed you running, so we don't have to type this stuff in again. So what I'm going to do here is I'm going to bring up a Finder window. Okay, so this is the new application that we are building. I'm going to get rid of a couple of these files, like the app delegate. I'm going to replace it with the version of the app delegate that comes from the original app. So I'm just going to pull that stuff in there. I'm going to replace both of those items. And so just to verify, we can come back in here now and we can look at these things and see that, in fact, now they are the updated version, even though we're in the new Wish app. You can see there are some errors here right now. Xcode's telling us things like it doesn't know about this file because this guy is actually not going to be part of our project, right? This is the model object, and we're going to be relocating that object into the framework instead. So we'll have to come back and address that issue in a few minutes here. The original Wish app project, when I created it here, it had a view controller. I'm just going to get rid of those files because we don't need that view controller. So I'm going to move them to the trash. Then I'm going to replace the storyboard. So I'm going to show that in the Finder. Okay, so this is the storyboard file from our new app. I'm going to come back over here to our initial version, grab this storyboard, copy it in on top of that. And now you can see in Xcode that in our new app here, we've got the storyboard with our custom cell. There's some errors and stuff right now, but we'll ignore those for the moment. And let's go ahead now and get our view controller for our table view, as well as our custom table view cell. So there's a couple files here we need. We need this class category for the view controller. We need the table view cell, and we need the table views view controller. So all of those files, I'm going to actually simply drag them and drop them right into the project here. I'm going to make sure this copy items, if needed, is checked. Make sure that the target is the Wish app, and hit finish. So now we've got all of those files in there, which should now mean, if we look at our storyboard, let's see what's the error here. Some error, oh, that's not even in here, that's different. So there's no error in our storyboard right now. And all right, so that our app won't run yet because we don't have, come we don't have the wish list item, right? We've got a wish list item cell. We've got a view controller that has an array in it. And everywhere we try to import this wish list item, we're getting an error. So what we're going to do now is we're going to go and add another target here for the framework. So we're going to create a target called wish kit. And in order to do that, we're going to come up here to the project. And in Xcode 6, actually, oftentimes this little border here or gutter is turned off. So this is what it might look like when you're looking at it yourself. We'll turn this guy on. It'll expose the list of targets. And down at the bottom, there's a plus sign here to let us add a new target. And under frameworks and libraries, it used to be that the only thing that was included here was Cocoa Touch static library. Now we've got Cocoa Touch framework, and we can hit next on that. We're going to call this framework Wish Kit. Again, in this particular example, we're using Objective-C. We could just as easily do this in Swift. The two additional items down here for the target are, it's asking us which project do we want to include this framework target in. And in our particular workspace here, we only have one, so it's Wish App. And then embed in application. So we could actually have inside of our project, it is possible to have more than one target that generates an application. In which case you would, from this list here, you would pick which app you want to embed the framework inside of. Xcode has picked the only app target we've got right at the moment, the Wish app. And so we're ready to go. All those things are set the way they should be. Hit finish. Now we have two new targets here. We have Wish Kit and we have Wish Kit tests, in addition to our Wish app and Wish app tests. So let's take a look and see what kind of code Xcode put in there for us. So let me open up both of these guys. And our framework now includes a very small amount of stuff. It includes the info plist, just like any bundle would, and that's where things like the version number would show up in the product name. So you can manage this stuff if you want to control sort of the metadata for the release of your framework. So they created that file for you, and then they create this wishkit.h file, which is like the public header file for your framework. And they include a couple of variables here for you that can then be used within your app to do something like report in a log message, for example, what version number of the framework you're using currently. So there's a WishKit version number and there's a WishKit version string. So two different formats for the same information. And then there's a comment down here at the bottom that says, in this header, you should import all the public headers of your framework using statements like #import angle bracket wishkit / public header.h. Okay, so we're going to have something in here that looks kind of like import wishkit / some header.h, right? That's what it's going to look like. And so the first thing is, notice how, with the framework, we're now using the angle brackets, whereas if we looked up here in our earlier code, you can see like here, for us to get from the wish list item cells.m file to pull in the .h, we use the double quotes, right? The double quotes are things that tell the compiler to search only the local folders for the header, for a matching header file. Whereas the angle brackets, what they're doing is they're telling the compiler to search through a completely separate set of directories to try and find that header. And those directories are the framework header directories, which I'll show you in a little bit. Okay, so we're going to have something like this for each one of the different header files for a model object that we want to expose from the framework. So I'm going to comment that out for a moment since that's not really what we're going to do. And let's add our files here now. Go back over here to Finder. And okay, so this is the original wish list application. And the source code we want to put in here is our model object, our wish list item. and I want to drop that into the wish kit. So I'm just going to drag it over here and drop it right there. Again, make sure copy item if needed is set. And notice how I now have 4 targets to choose from, whereas earlier I only had 2. Here I want to make sure wish kit is the one that's selected. And so now I've got these additional 2 files here, which means I ought to be able to now have a line that looks like this. Wishlist item.h. Okay. So that's saying that basically whenever someone imports WishKit, they should also get access to the wish list item. Now, in order to do that, because Xcode packages up all the framework code into a bundle where they also include the header files, we need to make a change to our header file that we just added. So if I select wishlist item.h from here, I don't need to make any change to the source code of it, but I need to come over here and look at the target membership. And you'll see that because this is a framework, Xcode has decided to go ahead and turn on the checkbox for target membership on the header file. Now, sort of to contrast this against what we're used to, if we come back up here to our Wish app and we select a header file, notice how that header file is not a member of any target at all. In fact, it makes no sense for a header file to be part of a target because a header file isn't something that gets compiled and included into the running application. It's only there for the reference of the compiler at build time. Well, with a framework, it's a little bit different situation. We actually, when we package up the framework, we need the header files that are public to go along with it and be part of what is available to the compiler when the framework gets linked against the application. So down here, our wishlist item.h, Xcode was smart enough to know that it needs to have the target membership turned on. And when you turn the target membership on for a header file in a framework, you also get a choice as to which type of header file it is. And so if I pull this open, there are 3 choices here. There's project, there's private, and there's public. Now, a project header file means that it is for a piece of code that is only going to be used internal to the framework project and is not going to be required when the application is actually, when the framework is linked against other code. Private means it's a header file that might be referenced by another header file that's part of your project, but it should never be referenced directly by someone who is using the framework. So it's typically used on Mac OS in larger frameworks. I don't know of a use for it really in iOS frameworks yet, but that's what it does. And then the third option here is public, which means the header file should be actually incorporated into the framework in a way that makes it referenceable by the consumer of the framework. And in our case, because over here in wishkit.h, we have this #import, it means we need to change the type of this header file's membership from project to public. And that will ensure that this header file actually gets included in a way that it can be referenced successfully by this line here. Okay, so we've got the WishKit public sort of wrapper header file set up correctly now. We've got our model object included. The other thing that I wanted to include into the framework is the images that go along with each of these items. So let's go back over to Finder and let's grab those images and include them. So there's 1, 2, 3, 4, 5. Okay, so I'm going to take these 5 images and I'm just going to drag them down into this supporting files folder. And like with everything else, I'm going to make sure copy files if needed is checked. And I want them to be members of the WishKit. And there we go. And now I can check each of these files, and you'll see that, again, their target membership box is checked. And so these binary files will actually be incorporated as part of the framework that is linkable and runnable by the application. Okay, so at this point, we can change our focus back to the application. And the first thing we want to do, I think, is we want to address this error that's up here. So let's look at the one that's in the app delegate. And so this is, we were trying to import wish list item. And what we really want to do is we want to reference the wish kit. So we pull in the entire framework now. Okay, so that gets us the kit. There was another error in the table view. I believe it's the same one. And we'll do the same thing. I love autocomplete, except when it gets in the way. Okay, so we've got wish kit in both places. There are no more errors associated with it. I can now build the application, and let's see what happens when we try to run it. Okay, doesn't quite look like what we were hoping for. So you can see that we've successfully constructed our model objects. And so that means that the object that underlies each of these rows in the table actually did come from code that's down here in the framework. But none of our images showed up. And that's actually because we've got a little bit of refactoring we need to do in our application to make this work. The old version of the app delegate did a whole bunch of initialization of these objects right inside of the app delegate. Obviously, this isn't really going to work anymore. I need to move this code. So I need to move it inside the framework somehow because the images now live over in the framework. So let's just take one of these lines and break it apart so you can kind of get an idea what it was doing. So each of these lines was using an initializer on the wish list item in order to construct one of the items by passing in the name of it, the URL for it, and the image that's to be used. So I've got 5 lines like that that are used to construct individual model objects. But the images that are associated with those model objects aren't really in the application anymore. They're now over in the framework. So what I want to do is I want to take these guys and get rid of them from here. And I want to come down here into the wish kit, and I'm going to add a new file here that's going to be like the factory to construct these things. And I'm going to call it wish factory. It's good enough. And it's going to be part of the framework, so it's going to be part of WishKit. And we'll just drag them up here so they're in the right folder. Okay, and so now inside this wish factory, I'm going to have a method that is going to be a class method that returns an array. Current wish list. Sounds good. And we'll add the code for that. And in the code, we will put the stuff that we just grabbed from the other part of the system. Now, it doesn't know what a wish list item is yet, so we can do a import wish list item. And now those just turn into warnings. And this error down here is because we're supposed to be returning an array, and we don't have an array to return yet. So we can say return an array. And then our array should have Tesla, Mini Cooper, iPad Air, iMac, and Apple Watch. Okay. So we basically just moved some code out of the app that's really related to the framework. And now we can come back up here to the application. Oh, there's something else. Well, let's just go up here and do this first and see what happens. Come up here to our app delegate. And now there's an error on this line where I was creating the mutable array because the mutable array was being created from an immutable array that doesn't exist anymore. So we can now say wish factory current wish list, and that should give us our array. But of course, there's an error here as well, right? Because I've added a new class as part of the framework, and Xcode doesn't know anything about this new class because I'm including the framework header file in which I forgot to add an import. And that should, I think, make the app delegate happy now. Okay, so now the app delegate is able to initialize its mutable array based on the current wish list that it got out of the framework. So we should be able to run it now and everything should be better. Okay, that didn't work. Let's see what we've got wrong here. Did I name it wrong? Oh, you know what I forgot to do? I forgot to take my header file for my wish factory and change it from project to public. So that's why the application couldn't find it. Let's see if it builds now. Okay, let's run it. And that didn't really help us very much, it turns out. So we've moved the code that deals with the model object construction into the factory that's part of the framework, which is the right thing to have done. But that didn't solve our problem with the images. And so I want to debug this a little bit and show you why that failed to work the way we were expecting. So each of these lines that constructs a wish list item takes 3 arguments. It takes a string for the title, it takes a URL for how to go to that website, and it takes a UI image. So what I would like to do is I'm going to set a breakpoint right at the beginning of this and rerun the application. And we're going to step through here. And if we just single step over this one line, now we can come down here and we can look at the Tesla wish list item, and you'll see what the problem is. Okay, so this image here is a nil pointer. So for some reason, the image failed to load. Now, we are using the method on UI image called image named, where we provide the name of it. And if we go over and look in our list here, it's clear that an image with that name does exist in our framework. So the question is, why didn't that work? And it turns out the reason is because the behavior of this method is to look for a resource with the name you specified in the main bundle of the application. So even though we're in this framework, which if you remember is an embedded framework inside the app, even though we're in code that's in the framework, we're actually trying to find an image called Tesla that's in the main bundle. So to fix this, we have to use a different method instead of image named. So instead, what we need to do is, actually first, well, let me just put this in first. UI image, Tesla image equals UI image. And so there's another method here, image named in bundle compatible with trait collection. Okay, and so this method, we can give it our thing there. And we need, we need a variable that contains the bundle identifier for our framework. We don't have one yet, so it's still an error, but just filling in what I'll imagine that the variable name will be. And the trait collection turns out to be something that, for our purposes right now, we can just leave nil. Okay, so that is the correct way for us to refer to a resource that is in our local framework bundle. So we need to figure out how to get this framework bundle variable. And there's a class called NSBundle. And we need to initialize it with something. There's a class method on NSBundle called bundle for class. And you can do that. And basically what you're saying is, please give me a pointer to the bundle object that is correct for the wish factory. So since we know that the wish factory is it lives within the framework, then this invocation where we're saying bundle for class, where the class is ourself, that's going to result in us getting back a bundle pointer that will refer to the correct thing. And so if we then come down here, we can take this stuff out and we can say Tesla image, and in theory, we should at least have one image working correctly now. So let's go ahead and run it again and stop at the breakpoint. And so we can see we've already run through the 2 lines for the framework bundle and for the Tesla image. And the framework bundle looks correct. It points at an interesting, so you can see the path to it is this lengthy path right here. This is where the framework is actually loaded in the simulator. And I'm going to copy that into the clipboard so we can go look at that folder in a few minutes here. And you can see that the Tesla image is a valid thing as well, or at least it appears to be. And let's see if we can actually look at that. So you can see right there in Xcode, we're taking a look at the image that was successfully loaded from our framework. Let me see if I can get that to go away. All right. And so now when we initialize this Tesla object, it should have a correct pointer now for the image. Okay, so I'm going to go ahead and just let this run. And in the simulator, we can see that at least one of our images is now correct. So I could make that same change for the other 4 of them here, and then all of them would be correct. But that's just more typing that I don't need to do at the moment, I don't think. Okay, so now let's go take a look at the actual location on disk where this framework is. We can dissect the framework a little bit and see exactly what is included inside of a framework. So actually, I'm going to take that, and we'll open up Finder, new Finder window, Command-Shift-G, which is going to prompt us to go to a particular folder. I'm going to paste in this path, and so this is the folder now that the simulator is running our application out of. Okay, and so what we've got in there is we've got the bundle for the application, we've got the framework, and we've got a bunch of symbol files and a bunch of test bundles as well. Okay, and so I can start out here by expanding out this framework, and you can see we've got the info P list, which is the thing you saw. Let me actually bring us back here. Okay, so here you can see the tree structure in Xcode of what our project for the framework looks like. And here on disk, you see what the final prepared version of the framework is. Let me actually just open this guy up. So now we're only looking at the stuff that's in the WishKit framework. So you can see that the info P list is here, and that matches under the support files here, the info P list right there. Okay. And then you can see the images are all here. Those all came from the project as well and got placed into the framework. We've got a folder for headers in which we've got our 3 public header files. So we've got the master WishKit header file plus the other 2 for the factory and the model object. Then we have the actual WishKit file. Now, this file, if we get info on it, this is the actual executable. So it's a Unix executable file, and it's called WishKit. We don't see the extension here, but it's actually wishkit.a. And so it's actually the library that we're linking against. And let's see, so then under modules, this module map thing here is actually, I don't believe it's used very much by Objective-C, but when we get into using frameworks in Swift, this describes the dependencies between the modules. Swift calls what we're calling a framework a module. Okay, so that's basically everything that's part of the framework. So if we go back up one directory here, so the nice thing about the way frameworks are packaged up is you can take this whole thing right here and stick it in version control or mail it to someone else, and they can drop it into Xcode and they can start using it. They don't need the source code to your framework at all. So if you were someone who wanted to distribute third-party components for use by other people, you now have a mechanism that lets you do that, whereas previously it was much more challenging to do it. Okay, so that's the framework sitting all alone by itself. Now, if you remember, I actually said frameworks are embedded inside of applications. So up here, Wish App, that's the actual application bundle that was prepared. I'm going to go show package contents on that. And if we look inside there, you'll see there's a folder called frameworks. And inside there, look what we've got. We've actually got a local copy of the WishKit framework embedded directly inside of our application. So all of this stuff here is what actually gets shipped to Apple when you submit your app for review. And that copy of the framework will live, forever basically as part of your application. If you ship another application that also uses the WishKit framework, it will have its own embedded copy of the framework. They'll be independent of one another. Okay, let's see. That's pretty much everything I wanted to show you in terms of how you use frameworks and how you can migrate existing code into a framework. A key thing I think to keep in mind is making sure you set the header files to be public for anything you want exposed and referenceable by the consumer of the framework, and making sure you're doing the right thing whenever you load resources, right? You have to make sure, for example, you have the correct bundle identifier or bundle NS bundle pointer. Otherwise, you'll get failures of loading and things like those images I showed you earlier. Okay, let's go back over here. All right, so basically what we accomplished was, right, we took wish list and we turned it into wish app and wish kit. It's a simplified example of what you could do. That's frameworks. So thank you very much. I'd like to open it up to any questions now. If you've got questions, feel free to type them in the chat window or in the little, I think there's a place where you can actually type a question directly in. And I'll try to answer them as best I can. If something comes up later on and you have a question, feel free to email me. I'll be posting a recording of this thing along with the GitHub link for the actual projects that I used in the example. So thank you very much.